Okay, so we'll start with our next topic, that is your network topology. Okay, so we were discussing about connectivity, like physical connectivity we were discussing, and logical connectivity, right? And in physical connectivity we already discussed our devices, network devices, and next topic was network topology, correct? Yes or no? So today we are going to cover network topology part, and then we'll cover, after this one we'll cover cables and all. Okay, so we'll start with network topology first. Okay, so first of all, what is a network topology? If I talk about network topology, basically it defines the physical structure of the network, or you can say physical layout, or you can say your design. Okay, so that is your called as network topology, physical structure of the network, that is called as network topology. Got it? So that means it defines how your devices are connected, whether they are connected through a single centralized device. Okay, there are multiple devices, suppose. Okay, I have 4 or 5 PCs and they are connected through a centralized device. Okay, so one of the example is like this. Okay, they are connected in this fashion. Or another one is I have 4 devices, they are connected in this fashion. Okay, they are connected to each other. Okay, so this is also it defines a physical layout, right? Physical design. But how you will come to know which topology it is? Okay, so that you should know, and where to use which topology. Okay, that you should understand. Clear? So if I talk about here, so these are some common topologies, okay, which is mainly used in networking. Okay, that we are going to discuss today. So first one is your bus topology. Then we'll discuss about bus topology. Then we'll discuss about star topology. Okay, then we'll discuss about tree topology. After that we are going to discuss about ring topology. Then next one is your mesh topology, and last one is your hybrid topology. Okay, so these are the mainly topologies which are mainly used in day-to-day networks. Okay, so we'll discuss one by one. Okay, and we'll see at the end of the topic we'll see where to use which topology. Okay, so if I talk about first one, first one is your bus topology. So in bus topology, basically the devices will be connected through a single cable. Okay, we can say devices are connected through a single cable, and that cable is called as backbone cable. Okay, so there is a backbone cable. Through that cable all the devices will be connected. Okay, so suppose I have a cable here, this is called as, this cable, that is called as a backbone cable. Okay, in bus topology, and all the devices will be connected through this backbone cable. Okay, here I have a PC connected, okay, using the cable, and here also I'm having a PC connected, here also I'm having a PC connected, like this. Okay, and in this bus topology there is a connector used. Okay, there is that connector is called as BNC connector. Okay, So basically this BNC connector, it's a T-shape, we can say it is a T-shape connector. Okay, this connector is used to connect the devices to the through this backbone cable. Okay, so we can say like how it will be, like it is kind of a T-shape. Okay, like this. Okay, so if you want to connect a system, okay, like suppose I want to connect a system here, so here I'm going to use a connector. Okay, so I will use a connector. So one end of this cable will be inserted here, one end will be inserted here, and the cable through which we are going to connect the PC, so that will be inserted on this side, on this point. Okay, so this connector is used to connect the devices. Okay, so similar here also, one connector will be used like this. Okay, clear? Any doubt so far? And similar for this. Sorry, hello, your voice is not clear. Hello, anyone? Any doubt? BNC is like it is an English name only. Let me show you. BNC connector in bus topology. Okay, see, Boynet Nail Concealment. Okay. Okay, wait. I'll copy paste. Okay, that name here. Now it's visible, right? So this is the name of BNC, its full form. Clear? So this is an English name only. So basically it is a T-shape connector. Okay, only the use of this connector is to connect the devices to the cable, through the cable. Clear? Yeah. Okay. But there are some drawbacks of using this cable, because nowadays we are not using this topology. Okay, so what is the main advantage? If I talk about an advantage of this topology, so advantage is it's very easy to understand and use. Okay, because just a single cable is there, and we have to, using these connectors, we have to connect the devices, right? It's very easy, right, to understand it. Okay, but there are lots of disadvantages. That's why nowadays we are not using this bus topology. Okay, what are the disadvantages? First one is single point of failure. Single point of failure. Okay, that means like if this cable goes down or break down, okay, so there will be like network outage will be there. These PCs will not able to communicate. Okay, yeah, I'm recording the video. Okay, so there is a single point of failure. Even this cable goes down, and also like there are other single point of failures. Okay, multiple single point of failures are there. Okay, in this topology. So what is that? Like see, here also like data, this bus topology. Okay, it share the data. Okay, send the data using shared media. Okay, shared media means like through a single media, through the single cable, it is sending the data, right? Okay, so suppose if this PC wants to send the data to this one, so it will be going through all the devices. Okay, so at the same time, if these devices wants to communicate, they will not able to communicate. Okay, and also like if this PC goes down, because all the data will pass on through this PC only, right? Okay, will through this PC only, through this cable only. So that also one of the drawback here. Okay, even cable goes down or PCs goes down, your entire network will not able to communicate. Okay, so that is the problem here because it uses a shared media. So also, like at the same time, multiple PCs they cannot able to communicate. Okay, at the same time, at a one time only one PC can able to communicate. They can able to send the data. Clear? So these are the disadvantages. That's why we are not using bus topology nowadays. Okay, nowadays we use star topology. Why? If I talk about star topology, in this star topology all the devices will be connected. Devices are connected through a centralized device. That device is you can call hub or switch. Okay, but as we discussed yesterday, we don't use hub nowadays, right? Okay, we use only what? Switch. So that means like in this one, in star topology, we are going to use a centralized device, that is your switch. Okay, and if you want to connect multiple devices, we can connect it easily. Okay, and also here, see, in bus topology, even if you want to extend your network, that means like if you want to add some more devices, okay, so what you have to do, we have to cut this cable from here, we have to like use one connector. Okay, we have to use the connector, right? Then only we can add the new device, correct, to this network. Yes or no? Okay, so that is at that given point of time when we are installing a new system to the network. Okay, so that means your network scalability is not good. Okay, so that means like it provide low scalability. Okay, if you want to enhance your network or enlarge your network, that is like not possible. Even possibility is there, but there is there will be a network outage, right? The other PCs will not able to communicate because your cable will be cut, right? Okay, so that is a problem here. But in this one, in star topology, if you want to add a new system here, if you want to add a new device here in your network, you can easily do that. It provides high scalability. Okay, the star topology. Also, like if this link goes down, okay, this cable goes down, okay, there is no effect on the other systems, okay, on this particular network. Clear? They will able to communicate. And also like it is not using any shared media. Okay, so that means like they can communicate at the same time, multiple PCs they can communicate at the same time. Okay, like if this PC like if the second PC it is communicating this one, so this PC also communicate to this one. Okay, like that. So at the same time multiple PCs they can able to communicate to each other. Okay, but here also there is a problem, that is if your centralized device goes down, then okay, that is like we can say a single point of failure here also exists. Okay, but for this nowadays we use some kind of a backup. Okay, so backup will be there, like if this goes down, okay, so there will be a backup. Clear? So that is how we use star topology. So advantage we can say like it is easy to use and it provides high scalability. Okay, but this star topology it is good for small networks only, but not for the like we can say large networks. Okay, for that we use like other topologies. Okay, so that we'll discuss our next topology, that is your tree topology. Hi Sohail, yes please. It's like in switch only. Suppose there are kind of CPUs, right? Okay, so there will be like one. There are suppose two CPUs. Okay, inside that. Okay, one is active and one is standby. Okay, so if there is any problem in one of the CPU, okay, so this will go down, right? Okay, the active one. So your standby will be act as an active. Okay, so in case of failure, your standby will act as active one, and your device will act as like working only. Then obviously there will be outage. It has to be troubleshoot, right? No. Okay, so next one is your tree topology. Okay, so in tree topology, basically the devices, they are connected in a parent child structure. Okay, parent child structure. So suppose like I have a building. Okay, so suppose this is a building here, and in this building I have multiple floors, right? Okay, suppose there are 3 floors. Okay, and in each floor I have multiple sections. Okay, like I have 2 sections, like section A and section B, like that. Okay, for each and every floor. Fine. Now on this section I have suppose 10 PCs, they are connected. Okay, here also suppose I have some 10 PCs. On this floor here I am having like 20 PCs connected. Okay, on this section, okay, I have some 20 PCs. On this side, on this floor, I have suppose some 15 PC connected. On this side I have some 10 PC connected. Okay, so how you are going to connect that? Using switches, right? Yes or no? Okay, similar here I'll use a switch and I'll connect those 20 PC. Here also I'm going to use a switch and I'm going to connect the PCs, okay, using the switch. So similar here. Okay, now we have to, like, on the same floor, if these PC wants to communicate to each other, okay, so these switches should be connected, right? Okay, so I'm going to use like a switch in between, okay, to connect both the switches. Okay, similar for this, on this floor I'm going to use a switch to connect both end switches. Okay, I'm going to use another here for this floor. Okay, and now if this PC, okay, sorry, now if these PCs wants to communicate to this third floor, okay, first floor PCs wants to communicate to the third floor PCs, so there should be connectivity, right? So what we'll do, we'll use a switch here, okay, so that will be connected to all these main switches. Okay, clear? So this topology will be look like this. Suppose there is switch and there are 3 switches connected to this switch. Okay, that means that those are your main floor switches. Okay, and then these switches, they are further, there are 2 switches are connected, right? Yes or no? And there we are end devices are connected, end users are connected, like that. So similar on this second floor, okay, there are 2 switches are connected, okay, like this, and then our end users are connected. Similar for this one, okay, so like there are 2 switches and our end users are connected. At the end here also, in tree topology also, we are using what? We are using kind of star topology only, but basically this tree topology used in large network. Okay, where we have like more number of users. Okay, so there we use tree topology instead of star topology. Star topology is good for small networks only. Clear? So this is a kind of a parent child structure only, you can see here. Okay, clear? Any doubts so far? Anyone? Yeah. Yes. It is used in the real life networks. Okay. Like spine leaf, we are talking about spine leaf kind of that. Yeah. So basically, these are used in the data centers only. Okay. Yeah. So see, like if you want to connect like 10 systems, okay, in a network, in a small network, so you have to use star topology only, right? So you are going to connect those pieces using a switch only, correct? Yes or no? Okay. So that is your star topology. Okay. Similar, like if you have a huge number of users, okay, so there, because on a switch side also, okay, on a single switch also there is limited number of ports, right? We can connect limited number of users only, okay, but if we have like more than 100 users or more than like 500 users, then you have to create it like in a tree topology structure, like this example I given you, right? In like if there is a building, like suppose there are 10 floors, okay, got it? So in that way, like it will be used, this tree topology will be used. Clear? Okay. So router basically used, see, basically like this is a single building only, single organization network only, right? Okay. So that means that is your a kind of a local area network only. So router, yeah, kind of single local area network, because your organization network is what? Your single LAN, right? Okay. All the users are communicating to particular that network itself, right? Okay. Working for the particular organization. Okay. So that is your a one network. So that is why we are not using any router. Router is used for what? To connect different networks. Yeah. Yeah. Clear? Next one is your ring topology. Okay. So ring topology, basically in this, your devices are connected in a ring, or you can say in a circle. Okay. So how? Like suppose I have 4 PCs, like PC1, this is connected to PC2, this is connected to PC3, and PC3 is connected to PC4, like this. Okay. Earlier, like ring topology used, okay, in like old networks, okay, but nowadays even we are not using this ring topology. Okay. So in this one, basically this ring topology based on token. Okay. So like whoever wants to send the data, okay, so like there is a token, okay, it will use that token, and that means like if this first user, okay, it is having the token, that means this first user can send the data, okay, and other users cannot send the data at the same time. Okay. So this is first of drawback we can say. And also in this, data flow will be in one direction only. Okay. Like this, in one direction, in clockwise direction only data can flow. Okay. It's not like if first device wants to send the data to first device sending data to fourth one. Okay. So it's not like it will send directly like this. It won't be possible in ring topology. Okay. So it will be like it will go through like this. Okay. In this direction itself. Okay. So this is a kind of, we can say, a logical layout or logical topology. Okay, so how your physical devices will be connected? So physical devices will be connected like this. Okay, there is a device called MAU device, media access unit device. Okay, this device is used to form a ring topology. Okay, so why we use this MAU device to form a ring topology? Because in this your ports are connected internally. Okay, like first port will be connected internally to the second port will be connected internally to the third port will be connected to the fourth port, and fourth port will be connected to your first port, like that. Clear? So that means this is what? This is kind of circle, right? Yes or no? Okay, so then we can connect our systems like on these ports. Clear? So if this PC wants to communicate to this one, third PC wants to communicate to this second PC, so data flow will be like this. First will go like this, okay, like that. Clear? Okay, but nowadays we are not using this ring topology because this is very old. And here also there is single point of failure, we can say. Okay, clear? Now next one is your mesh topology. What is mesh topology? So in mesh topology, each and every device is connected to each other. Okay, how? Like suppose I have 4 devices. Okay, so they will be connected to each other. So that is your mesh topology. Okay, like this. If I want to include one more device, okay, if I want to add a more device to this network, so what we have to do? We have to like connect this particular device to all the devices. Okay, like this. Clear? But usually we don't use this topology in our local area networks. Okay, why? Because in local area networks we have a lot of number of devices, right? Yes or no? So see, if I need to connect 5 devices, okay, how many cables you are using? Like 1 2 3 4 5 6 7 8 9, okay, or 10, right? Total 10 cables you are using, okay, to connect 5 devices. Again, if I need to connect one more device, how many cables you have to purchase? 1 2 3 4 5 to only connect one device, right? And earlier it was already like 10 cables were there, okay, and plus 5, okay, total how many cables you have used? 15. If your network, like if there are 100 devices, okay, then that's not possible, right? Even like to troubleshoot also, like it will be very hard to troubleshoot. Even if one of the cable goes breakdown, okay, it will be hard to troubleshoot, like which cable goes breakdown, right? Yes or no? But there is some advantage also. What is that advantage? It's not like we are not using this mesh topology. We use this mesh topology, but basically it is used on WAN side. Okay, that we'll discuss later. Okay. So, what is the advantage here? See, suppose I'm using here switches. Okay. So suppose they are interconnected to each other, like this. Okay. So in star topology, suppose this is the star topology. I discussed like suppose this cable goes down. So this PC now, it has no access to the other systems, right? It won't be able to communicate to the other system. Yes or no? Correct? But here in the mesh topology, there are multiple paths available. Suppose here one PC is there, okay, and if this goes down, okay, if this cable goes down or this path goes down, okay, so there are multiple paths to reach to particular this network, okay, like that. So see, if this cable goes down, so there are other paths available like this way or like this way, correct? Okay, so that is your mesh topology, okay, where your devices are connected to each other. Clear? Any doubts so far? Anyone? Saurav, Nayan, Naveen, Kaushik, Farnaz, Dhruv. Yes or no? Okay. And now we discuss about our last topology, that is your hybrid topology. So hybrid is nothing like, we can say this is your sixth one, hybrid topology. Hybrid topology. So this is like, we can say it is combination of two or more topology, okay, combination of two or more above topology, okay, which we discussed, right? Okay, so suppose there is a star topology, okay, like this, okay, through this one switch is connected, okay, and there is another a mesh topology is there, okay, like that, they are connected to each other, okay, so like this. Clear? So here we have what? We have star topology, okay, this is what? This is a star topology, right? And this is what? This is a mesh topology. So the network in which we are using like multiple topologies, okay, in combine, so that is called as hybrid topology. Got it? Any doubts so far? Yes. So basically that now I'll discuss that only. We have to use which topology, okay? That is we use mesh topology, okay? So let me discuss that now, okay? So where to use which topology, okay? So if we talk about, if there is a small LAN local area network, okay, so in that case we use star topology, okay. Suppose we have 10, 20 or 30 pieces, okay, we have to connect, we are 30 users are there, okay, they want to communicate to each other, okay, in a local area network. So we use what? We use star topology, okay. If there is a large local area network, in that case we use tree topology, like if there are 200 or 500 users, right, okay, so in that case we use tree topology, where we can connect like multiple switches in a parent child structure, okay, and end users can connect to those switches. Clear? And we use, if you talk about like in WAN, on the internet side, we use mesh topology. Why we use mesh topology? See, suppose like there is a Cisco office, okay, so in each and every city we have Cisco office, right, okay, like mostly. So suppose like in like this is my one location, like Delhi, okay, in Delhi I have a Cisco office, okay, that is my Cisco network, okay, is Cisco branch in Delhi. Similar, I have a branch here in another city, okay, like in Bangalore, BLR. Similar, I have a branch in another city, okay, like in Pune. And similar, here I have a branch in, suppose, Hyderabad. Okay. Now, how they will be connected? They will be connected through internet only, right? Yes or no? Correct? Okay. So now, like, if this PC wants to connect here, okay, so there should be communication, right? Okay, all your communication going through which media, or which, we can say, like, which transport? Okay, so going through your internet only, right? Correct? Hello? Yeah. So this is, we can say, so this is your ISP, internet. Okay, through internet you are communicating, multiple branches are communicating to each other. Okay, so now in case, so usually what happen, like, in case if this link goes down, okay, what will happen? See, this Bangalore branch, okay, they wants to communicate to Hyderabad branch. Okay, so even like if we are not going to use this mesh topology, then what will happen? Suppose there are no multiple paths available, okay, and there is only single path available, this path, and this goes down, so your communication will be drop, right? Yes or no? Okay, they won't be able to communicate, right? Okay, but you are paying service, you are paying to the ISP, right, for the services, internet services, correct? Okay, so that is why there are like, they on the ISP side they use like mesh topology, where we have multiple paths available to reach to the destination. Okay, so in ISP side we use what? We use mesh topology, so that like even if one of the link goes down, so there should other paths should be available, okay, to reach to that particular destination. Okay, like this way also they can reach. Yeah, some kind of backup paths will be there. Yeah. Okay, clear? In that case, like, see, even if it is like from the same ISP, but that depends like whether which your link is down. Okay, if your both the links are down, then obviously there will be a network outage. Okay, if the both links will be down, that means network will be there will be network outage. Okay, so you will see like in our networks usually like what happen, there are multiple services. Okay, we like companies take multiple services from the ISPs. Okay, there are like active link and passive link, right? Okay, one link they are taking suppose 1 GB, okay, service, or from other side they are using only 100 MB only, okay, as a backup. Okay, so suppose this goes down, so still the other link will be there, okay, so that like they can communicate through this link. Okay, but still like in this your whole ISP goes down, that means like your both of your links goes down. In that case there will be a network outage. Okay, so that means there won't be any communication. Okay, so this is your like about your network topology. Okay, a basic idea. Okay, now we are going to discuss cables. Okay, about cables. So first of all we are going to discuss cables which we use in our network devices. Okay, so if I talk about like cables, so cables are used for what? To make, yeah, to make physical connection, okay, to the device. Basically these cables also used to make the physical connectivity, as well as to configure the devices also we use the cables. Okay, so basically like if I talk about cables, there are two types of cables. Okay, we can say like physical connectivity cables. Okay, one is your called as like configuration cable. Okay, so here first of all I'm going to discuss about three cables. Okay, so your physical connectivity cables are, we can say like straight cable, second is your crossover cable, this I'll show you also. Okay, and this configuration cable, this is called as rollover cable, or you might have heard about console cable, right? Yes or no? Okay, so these cables we use in our network devices basically. Okay, so like to make the physical connectivity we use what? We use straight cable or cross cable. Okay, so where to use straight cable, where to use cross cable. Okay, so that we'll discuss first, and then I'll show you like how you can identify which one is your straight cable and which one is your cross cable. Okay, you can easily identify that. Clear? So these physical connectivity cables, these are used for connectivity purpose only. That means using this cable you can make the connectivity only, you can make the physical connectivity only. You cannot configure the device, okay, using these two cables. Clear? You can only connect if you want to send the data or if you want to communicate from one device to another device. So you can use this cable, either straight cable or cross cable. Okay, but if you want to configure the device, suppose I want to configure a router or I want to configure a switch. Okay, so you have to use which cable? Configuration cable. So we can say this is used to configure the network device. Okay, clear till now? Okay. So now first we'll discuss about like these physical connectivity cable. Okay, connectivity cable. So these are what? First one is your straight cable and second is your crossover cable, right? So this straight cable basically it is used to connect two different kind of devices, or you can say two different layer devices. Okay, so suppose like if you want to connect a router which work on OSI layer 3, okay, and you want to connect this router to a switch, okay, which is part of layer 2, yes or no? Correct? If you want to connect two different layer devices, we use what? We use straight cable. Okay, any doubt till now? Okay, and this cross cable basically it is used to connect two same layer devices. Okay, for example, I want to connect a switch to a switch. Okay, so here like in this straight cable, if I want to connect a router to a switch, I'll use which cable? I'll use a straight cable, right? Yes or no? And here if I want to connect a switch to switch, I'll use a crossover cable. Okay, like this. This is your crossover cable. Okay, let me show you this. Okay, So see, like I'm going to use a router. Okay, let me share this screen here first. So it's visible, my packet tracer is visible, right? Yes or no? So I'm using a router and I'm using a switch here, okay? And I'm using I'm going to use a PC. So all are what? Different layer devices, right? So which cables we are going to use? We are going to use C. If you see here, below if you see here, okay? This is what? Straight through cable, right? Yes or no? Copper straight through, okay? And this is what? Copper crossover cable, okay? So if I have to connect like two different layer devices, so I have to use straight cable, okay, like this, okay? Using the ports I can connect. Clear? So this is like this cable we can use to connect two different layer devices. Similar, like if I have another switch here, okay, suppose I have a switch here, and now I want to connect this switch to this one, okay? So what I'll use? I'll use a crossover cable, okay? Clear? So this is how you can identify it, okay? You can also make practice if you have the packet tracer installed in your system, okay? Later on also, like once we finish with the subnetting part and OSM model, okay, after I'll show you like how to install the packet tracer, so that like when we start our router configuration part, okay, so you will have your packet tracer handy so that you can also do the practice, okay? Meanwhile, like if you want to do it by yourself, you can do that, okay? You can install it in your system and you can make the practice, okay? Yeah, from Google itself you can download, okay? It's like free to use only. Now third one is our, so these two are what? So these are two used for connectivity. Yes, Suhail? Yeah, there are like in the cable, okay, that I'll show you. So in the cable itself, okay, there is connectivity is there, okay? There are multiple small cables, okay? So there is a difference, okay, that I'll discuss later on. So that is why it is used, different cables are used for the same kind of devices and different kind of devices, okay? That we'll discuss, okay? So these both cables part of what? Part of connectivity cable, right? Both are used for connectivity only, to connect the devices. So here also, if you see here, so these are what? We made the connectivity, right? Okay, so this is your connectivity. Now we'll discuss about next one, that is your configuration cable, okay? So that is your rollover cable. So basically this cable, it is used to configure the network device, okay? Basically you like call it as console cable, okay? So console cable, it is used to configure the network devices. So how you are going to configure the network device using this console cable? So suppose this is a router, okay? So on the router there is a port called as console port, okay? And on our system, okay, so what we have to do, we have to connect, we have to use a cable. Which cable we have to use? We have to use a console cable, and we have to connect this console cable to this console port of the router. Okay, and other end we have to connect to our system, and in our system like we can install like PuTTY software. Okay, using this PuTTY software we can configure our router, okay, from our system, okay, in the CLI. Clear? No. That is your unshielded twisted pair, right? Okay. So that is like we can say a part of the copper cable, right? Okay, there are two types of copper cable. One is like UTP, unshielded twisted pair, okay, and one is shielded twisted pair, okay. So that we'll discuss later on. Clear? Hello? Any doubts so far? Yes. It should be like locally, it should be there. Okay. Then we'll discuss later on, like we use some protocols like telnet, SSH, okay. Using these protocols we can configure the device remotely. So that we'll discuss later on, how to do that. Okay, so this is a good question. Okay, so basically this console cable, it is used to configure your system, okay, your network device locally. Okay, locally only you can configure it. That means that from that system from which you are going to configure the device, right? Okay, that should be present there in local. Okay, any doubt? Anyone else? That is what I told you, right? There are other ways like to configure it through remotely, okay. So that part we'll discuss later on, okay, how to do that remotely. Yeah, you have to configure some like some lines, okay, we can say like some VTY lines, okay. And once we configure that, there are lots of things we have to do. Even we have to make the connectivity, because without the connectivity, physical connectivity must be there, right? Okay, without the connectivity you won't be able to configure the router, right? Okay, so connectivity should be there, and then only you can configure. Without console you can configure through the whether telnet or SSH, okay. So that part will come later, and definitely like you will easily you can easily do that, like configure a router or a switch using telnet or SSH, okay. So that will be like in depth session, okay, on both telnet and SSH. Clear? Sorry? Okay. So now, like if you talk about how you are going to identify like whether this is a straight cable or cross cable or a rollover cable, or we can say console cable, okay. So how we are going to identify? Okay, so basically like if I talk about a cable, okay, suppose this is a cable, okay. So there will be some like two ends will be there, right? Okay, this is a first end, okay, like we can say this is our first end of this cable, and this is we can say a RJ45 port, okay. And similar RJ45 connector we can say, okay. And similar here also, the other side also, this is also a RJ45 connector used here, okay. So here this is the other end, okay. Now on this cable, okay, this is the cable. So in this cable we have small 8 cables, okay. There are small 8 cables present, okay. So how many? 6, 7 and 8, Okay, so how we are going to identify whether this cable is our straight cable or cross cable? Okay, so basically, like in straight cable, I'm mentioning here like small, suppose these are your 8 cables. Okay, 1 2 3 4 5 6 7 and 8. Okay, these are small 8 cables inside that particular one cable. Okay, so this is one cable only. Okay, and this is the RJ45 connector. Okay, through which you can connect. Okay, one side you can connect to your switch and one side you can connect to your PC, like that. Okay, clear? Got it? So these are your 8 cable. Okay, so first, second, third, fourth, 5th, 6th, 7th and 8th. Okay, so in straight cable, okay, there is a color coding. Okay, so that I'll show you. Okay, in the Google itself. Okay, what is the color coding? But here you can easily identify that in straight cable, suppose if here color code is suppose orange. Okay, the first cable here orange on this side, on this end, so other end also if it is orange, so that means one is connected to one, second is connected to second. Okay, how? That means like suppose first one is your orange and second one is suppose your white brown. Okay, like that. So here also if it is white brown, so that means here first cable, the same side, here also we are having the same color. Okay, for that particular cable. So in straight cable the connectivity will be like first to first, second to second, third to third, fourth to fourth. Okay, fifth to fifth, sixth to sixth, seventh to 7th and 8th to 8th. Okay, like that it will be connected. Okay, so let me show you that color coding also. Color coding for straight cable, right? See in this one, in straight cable, if first one is a green white. Okay, just hold on. Now let me share it with you. So this is visible, right? Hello. Okay, so see in this straight cable, okay, your first cable, this is your green white. Okay, so you'll see like some green color is there and white is there, right? Okay, so on this side, on this end, if you are green white, so this other side also it should be green white. If it is green on the second side, on the second cable is your green, so on other side also your second is green. Similar here, third one is orange white. Okay, so if it is like white orange on this side, okay, one side, other side also it is orange white, so that means you can say this is your what? Straight cable. Okay, so see, same, 4 to 4 both are same, right? 5th to 5th, 6th to 6th, 7th to 7th and 8th to 8th. Okay, brown. Clear? Okay, so this is your straight cable. Okay, let me share this again. It's my now it's visible, right? Okay, so that is what I discussed here. So that means that color code, okay, if it on first cable, if it is like white green, so here also it should be white green. If it is green here, so it should be green here. If it is blue here, so it should be blue here, like that. Okay, so you can easily identify it. That means that is your straight cable. So if I talk about like crossover cable, so in this one, like suppose there are 8 cables, right, inside that cable, 8 there are total 8 small cable, right? Okay, so in this one, like this is the first end, okay, we can say one end, and this is your second end. Okay, 1 2 3 4 5 6 7 and 8. Now in crossover cable, your first cable, okay, it is connected to the third one, and your second cable, this is connected to your sixth side. That means if it is orange white, okay, if it is orange white here, so this orange white color you will see here on the third cable will be your orange white here on the other side. Okay, if it is green here color, if it is green here on the second, so here it will be sixth number. Okay, just an example I am giving you, but if you see the pic is visible to you. Hello. Okay, so if you see here, see first one, it is connected to third, to the other side, right? So orange, the first one is what? White green. Okay, so white green is first here, okay, on this side first number, so other side it is on the third number. Okay, similar here, if it is like we can say green, okay, so here on the sixth number it is green. Okay, on here if you see first number, so similar here third number, it is connected to the third number. Okay, and rest will be the same. So here first is connected to the third, and second is connected to the sixth one. Okay, and fourth is connected to fourth, fifth is connected to fifth, seventh is connected to seven, and eighth is connected to eighth. Okay, like brown is connected, like if eighth one is brown, so here also it should be brown. If it is like white brown, so it should be white brown. Okay, if it is here blue, so it should be here blue. Okay, but using this one, like you can identify easily. If your first is suppose green white, okay, so here third number it should be your green white. So if it is green white on the third, and here first number green white, so you can say that that is your crossover cable. Clear? See, any doubt? Yes. Yeah, so basically this is the color code only. Okay, like see, basically this is, we can say, computer hardware. Okay, part of computer hardware. Okay, that making the cable and all. Okay, so this you can check here. Okay, there are codes. Okay, like 568A, 568B, like that. Okay, using those codes you can identify. That is what I'm saying. There are different codes. Okay, like 568A code is there. Okay, there are standards. Okay, like 568A, 568B. Okay, using those standards, okay, you can check the codes. Got it? So that means like in 568A, it is the code standard is like green white, then green, then orange white, then blue white, then orange, like that. Okay. Yeah, by default it is mentioned. Yeah. Okay. Yeah. And next one is what? Your console cable. How you are going to understand, like this is your console cable. Okay, so in console cable, basically like your cables will be represented as like this: 1 2 3 4 5 6 7 8. So this is your like total. In one cable there are total 8 cables, right? Small 8 cables. Yes or no? wait, okay. Similar we have other end also, right? 1 2 3 4 5 6 7 and 8. So in this one, in console cable, or we can say rollover cable, okay, your cables are connected in like in the opposite direction, okay. Like first one is connected to the 8th, okay, second one is connected to the second last, third is connected to the third last, like that, okay. Fourth is connected to the fifth one, fifth is connected to the fourth one, like this, okay. Clear? So here if it is like green white, if the color is green white on the first side, so on the 8th number you will see green white color, okay. Hello? Yeah, if it is like orange here on the second number, so here on the 7th number you will see the orange, okay. If it is here, if it is on first number on this side brown, so this brown should be here on the 8th number, okay. Clear? So this is how you can identify whether this is your console cable or your crossover cable or the straight cable, okay. So for basic understanding only I am explaining this, but basically this is mainly part of, we can say, computer hardware networking only, okay, not for the we can say like in Cisco networking, okay. But still this is useful, so I'm just explaining it. Clear? Hello? Any doubts so far? Yes, yes. 1 and 2 is transmitting, and here on the other side it is receiving, okay. And that is one of the guy having one question, right? Why they are different, okay? Why they are using two different cables, right? For the connectivity, straight and cross, right? Okay. This is the main reason, okay. So here if like for these different kind of devices, okay, so if one end is transmitting, other end is what? Here receiving, but this is what? With the same cable itself, okay, same side. First is on the first side, second is second side, like that, okay. Clear? That I need to check. Basically, see, cable bandwidth depends on like which interface you are using, okay. So that which cable you are using, okay, whether it is a fiber cable or copper cable, that also depends, okay. So because fiber cable, there also in fiber cable also there are different modes, okay, single mode cable or multi mode cable, okay. Single mode cable provides like 100 GB bandwidth, up to 100 GB bandwidth you can get the speed, okay. So that depends on the cable, we can say. Yeah. No. All the pins are not. Yeah. Correct. Or not all the pins are using. Okay. Yeah. So basically, this is shown as like these are used to send or receive the data only. Okay. Between the devices. So if the other information is going to receive, that is done by the other cables. Okay. So some other signals has to send to the exchange between the devices, right? Okay, so that is done by the other small other cables like 4, 5, 7 and 8. Okay, so these are basically used for transmitting or receiving the data. Okay, these first 2, 3 and 6. Clear? Hello? Okay. Okay, so this is about cables, okay. So now we are going to discuss our next topic, that is your IP address. Okay. Hello, I'm audible. Our next topic is what? IP address. Okay. So till now what we discussed, we discussed about physical connectivity, right? In physical connectivity we already discussed about our physical network devices. Okay, we discussed about our network topology. Okay, like in which design the devices will be connected. Okay, and we discussed about cables, like which cables we are going to use for the connectivity or for the configuration. Okay, so physical connectivity we discussed so far. Now we are going to discuss about logical connectivity. Okay, fine. So if I talk about IP address, so what is IP address? Basically IP addresses, these are, we can say, these are set of rules. IP addresses, these are set of rules to provide, sorry guys, so like I was discussing about IP address. So these are set of rules to provide logical connectivity. Okay, clear? So we'll understand about the IP addresses. Okay, in based on the rules only. We'll discuss few rules, and once you learn all the rules, okay, once you understand all the rules, it will be easy for you to understand the IP addresses. Okay, so if I talk about like IP address, so yesterday we discussed about INA, right? Internet Assigned Number Authority. Okay, so it divided your IP address into two parts. So what are those two parts? IPv4 address, IP version 4 address, there are two versions, and IPv6 address. Okay, so what is the difference between these two in IPv4 and IPv6? So basically this IPv4, it is a 32-bit long address. Okay, its size is what? It is 32-bit long address, whereas this IPv6, it is 128-bit long address. Okay, and this IPv4, we represent this IPv4 in decimal format. Okay, we represent IPv4 in decimal format. That means like in 0 to 9. Okay, but this IPv6 address, we represent this in hexadecimal format. Okay, clear? So even there are lots of more differences available. Okay, that we'll discuss later on once we cover this IPv6 section. Okay, so at that time we are going to compare both IPv4 and IPv6. Okay, so first we'll start with IPv4 address. Clear? Any doubts so far? Anyone? So if I talk about IPv4 address, so as I discussed, so I'm going to explain this IP addresses in some rules. Okay, so you have to follow the rules, or you have to understand the rules. Okay, once you understand all the rules, that means you can easily understand the IPv4 addressing. Okay, so what are those rules? So our first rule is rule number 1. Okay, so that I already discussed here. Like this is a 32-bit long address, right? So that is only your first rule. So you can say like it is a 32-bit long address and divided into 4 octets. Divided into 4 octets, okay, and each octet separated by a dot sign, okay. So like this. So there are total how many octets are there? 4 octets, okay, and each and every octet separated by a dot sign like this. Clear? So octet means what? In octet, in a one octet, if I talk about one octet, how many bits are there? There are total 8 bits. Okay. So 8 bits here in first octet. So total 4 octets are there, right? 8 bits here, 8 bits here, and 8 bits here. So how many total? Total is 32. Okay. Yeah. So this is your first rule. Okay. Let me show you this. So if we go to let me open my network settings. So just you can run this command like ncpa.cpl. Once you open this, so it will open your network connections. Okay. So if I want to show you this IPv4 addressing, okay, so on any adapter, okay, network adapter, you can configure the IP address. Okay, so like this is one of my Ethernet adapter, okay, but this is not in use, this is disconnected, so I'm just explaining here. Okay, so this is how you can do that. Let me show you again. So you have to right click, then you have to go to properties. Okay, so in this properties you have to like drag it down, so you'll see here Internet Protocol version 4. Okay, even there is IPv6 also. Okay, so right now we are discussing about IPv4. So I'm just selecting IPv4 and I'm going to properties. Okay, so I'm using like use the flowing IP address. See, so how many octets are there? 4 octet, right? Yes or no? Total 4 octets are there in IP address. Okay, and here you can see these are separated by a dot sign. Okay, if I show you here, see 10.0.0.1 like this. So this is one of, suppose this is my IP address, okay, for this particular adapter, and here you can see this each and every octet separated by a dot sign. Clear? Any doubts so far? Okay, so this is your first rule. My screen was visible? That setting and all which I'm showing you. Okay, okay. Now, second rule, rule number 2. Now, how many bits are there? Total 8 bits, right? Okay. So, in each octet, we can have minimum value as 0 and maximum value as 255. How? So basically like bits are there, right? So bits means what? On and off bit, right? 1 or 0, on and off bit. Okay, so in each and every octet, either your all the bits, like all the 8 bits, okay, in each and every octet, it can be like all the bits are on or all the bits are off. That is your minimum value or maximum value, right? Yes or no? Correct? So like in each octet, suppose like this is my first octet, okay, so my minimum value is what? So all the bits are 0, all the 8 bits are 0. Okay, so that means that is your minimum value, right? Okay, so this is my minimum value. So if you convert this binary into decimal, okay, so how you can convert that? So yesterday also we covered that, right? So basically, like 2 raised to power 0, 2 raised to power 1, 2 raised to power 2, 2 raised to power 3, 2 raised to power 4, 2 raised to power 5, 2 raised to power 6, 2 raised to power 7. Okay, this is how. So if you want to convert this binary into decimal, so you can convert like this. Okay, from right to left you have to go. Okay, and for each and every bit, okay, you have to do it via 2 raised to power 0, 2 raised to power 1. Okay, like that. Okay, and after that, like, you have to add all the values. Okay, so or else you can note down like this. Okay, like 1, 2, 4, 8, 16, because that is equal to that only. See, 2 raised to power 0, any power value, any number power value, power 0 is 1 only. Okay, if you say 2 raised to power 0, that is 1. If you say 3 raised to power 0, that is 1. 1 raised to power 0, that is also 1. Okay, so any number power value is any number power 0 is 1 only. Okay, so here 1, so 2 raised to power 1, that means, like, if it is on, that means 2, right? Yes or no? So 2 raised to power 2, that is your 4. 2 raised to power 3, that is your 8. 2 raised to power 4, that is your 16. 2 raised to power 5, that is your 32, like that. Clear? Any doubt? So here, if you calculate this, so 2 raised to power 0, that is your 1, multiply by 0, so that will be your 0, plus 2 raised to power 1, 2 multiply by 0, that is your 0, plus 2 raised to power 2, 4 multiply by 0, 0, plus, so any power 0, and we are multiplying it with any power. Okay, like we are having any number of power, suppose like 2 raised to power 5, but we are multiplying it with 0. Okay, so that means that is going to be 0. Correct? Yes or no? Okay, so here all the values for each and every bit is going to be 0 only, and we have to add all the bits value. Okay, so at the end 0 you can add, all the 0 you can add, and it will be your 0 only, right? So minimum value is what? 0. Correct? Okay, now we'll add maximum value. Okay, so maximum, it could be your all bits are on, right? Okay, now we'll calculate 2 raised to power 0, 2 raised to power 1, 2 raised to power 2, 2 raised to power 3, 2 raised to power 4, 2 raised to power 5, 2 raised to power 6, and 2 raised to power 7. Okay, now see, 2 raised to power 0, 1. 1 multiplied by 1, 1, right? Yes or no? 2 raised to power 2, 2 raised to power 1, 2. 2 multiplied by 1, 2, right? 2 raised to power 2, 4 multiplied by 1, 4. 2 raised to power 3, 8 multiplied by 1, 8. Okay, or else you can do like this way: 1, 2, 4, 8, 16, 32, 64, 128, because 2 raised to power 7 is equal to 127 only. Okay, clear? 2 raised to power 6, that is your 64 only. 2 raised to power 5, that is your 32 only. Clear? So at the end we have to add those values, right? Okay, so 1 we have added, 2, 4, 8, then 16, 32, 64, and 128. So if you add all these value, 128 plus 64, 192, 192 plus 32, 224, plus 16, 240, plus 8, 248, plus 4, 252, plus 2, 254, plus 1, 255. Clear? So that is what I explained here, like minimum value it could be 0, and maximum value it can be, maximum is what? 255 in each and every octet. Okay, clear? So that means, like, in each and every octet we can have, there are total 4 octets, right? each and minimum value it can be 0 and maximum it could be 255. Yes or no? Any doubt till now? Anyone? Okay, so that is your rule number 2. Okay, now we'll discuss about next rule, that is your rule number 3. So are you guys also making the notes right now in the background? Anyone? Please don't do that, just focus on the class. Okay, like recording will be available on the same day itself. Okay, you can revise the lecture as well as you can make your own notes. Okay, so it will help you to revise it also, you once you make it a note also, right? Okay, during your revision. Okay, so it will be easy for to understand it. Okay, and also easy to learn it. Clear? So right now just focus on whatever we are explaining. Okay, don't make the notes. Okay, because your half focus will be there on making your notes, right? Yes or no? Correct? Okay, so just leave your notes. Okay, just focus fully on the class. Clear? Hello? Yeah, so notes and all you can make it. Okay, I'm not denying to make the notes, but that you can do during your revision. Okay, clear? Yeah, because otherwise you will skip one or two things. Okay, you will not understand it properly. So just focus here. Notes you can make anytime. Okay, by revising the lecture, because that will be, the recordings will be available to you. Okay, for lifetime. Okay, now rule number 3. So these numbers, okay, so how many numbers are there? 0 to 255. Total how many number? So these 256 number, because starting from 0, these 256 numbers are divided into 5 different classes. Okay, so in IPv4 there are 5 different classes. Okay, and these numbers are divided into these 5 classes. Okay, so what are those classes? These are class A, class B, class C, class D, and class E. Okay, so basically class A, its range is what? So how you are going to identify, because these are total is what? Range is what? In 1 octet it's from 0 to 256, right? Okay, so these numbers are divided into 5 classes. Okay, so there is a range defined for each and every class. Okay, so what is that range for class A, for class B? Okay, that we'll discuss now. So class A range is, it is starting from 1 to 127. Okay, 1 to 127. Why we are not using 0? Because 0 is not in use, is reserved. Okay, basically 0 is reserved for the default gateway and all. Okay, clear? For the default routes we can say. So we don't use 0. Okay, the IP address, it should start from 1 itself. You cannot use 0 because this is a reserved one. Clear? Okay, so this is the range from 1 to 127. That means that is your class A IP address. So if any IP address suppose 10 only, I'm saying 10 dot something. Okay, so that means that is your class A IP address, because this belongs to this range, right? Yes or no? Clear? Yeah. Now class B range. So class B range is starting from 128 till 191. Okay, this is class B range. Similar for class C range, this is your 192 to 223. Class D range is 224 to 239. Okay, and class E range is 240 to 255. Okay, so these are the ranges for each and every class. Any doubt so far? Clear? Now our next rule, rule number 4. Okay, before that let me ask you one question. Okay, so suppose I have an IP address, suppose like 72.16.0.1, and I have another IP address like 172.0.0.1. okay, I have one more IP address, for example like 200.0.0.1, not 001. okay, let me give another example. Okay, so one example is like 72.172.200. like 254, like this. Okay, this is one example. Okay, and second example is, this is one IP address. Okay, second IP address example is what? Suppose I have an IP address 130.10.0.220. okay, this is one of the IP, and another IP is, suppose 192.168. okay, 0.254. okay, now I have 3 IP addresses. Okay, so if I see here, okay, in this IP on the first example, okay, so this 72, it belongs to class A range, right? Yes or no? This 172, it belongs to class B. Okay, and 200, this belongs to which class? This belongs to class C, and this belongs to class E. Yes or no? Correct. So how you are going to identify like this IP belongs to which class? Because here we are using like mostly all the classes range, right? Yes or no? Correct. Numbers are there, right? From all the range. Correct. So how you are going to? Yeah. So that is your because your there is lots of disturbance from your side in the background. That defines your network ID portion. Okay, from subnet mask you will come to know like this is your network ID portion and this is your host ID portion. But how you are going to identify that this belongs to? Yeah, that is what I'm saying. In this IP address, so this is my IP address like 72.172.200.254. okay, so in this IP address we have mostly like numbers from each and every class. So this belongs to like A, this belongs to like B, this belongs to like C, this belongs to E. Alright, yeah, so that is only our next rule. That is your rule number 4. Okay, how to identify like this IP belongs to which class. Okay, so that is our next rule. Clear? So we can say like first octet of an IP address always defines the class of the IP. Okay, so always you have to check the first octet. Okay, so using the first octet only you can easily identify whether this belongs to class A, class B or class C. So if we check here now, okay, so the first one, okay, this is 72, right? This is your first octet, correct? So these numbers belong to class A, correct? So that means this is your class A IP address. You don't need to check the other numbers, okay, other octet numbers. Clear? You have to only check what? you have to check only first octet to identify the class. Okay. Similar, this one, it is starting from first octet is what? This is 130. This belongs to this range, right? Class B. So this is your class B IP address. Similar, this 192. Okay, this belongs to class C. Okay, this belongs to this range 192. That means this is your class C IP address. Clear? Any doubt? So always you have to check what? You have to check first octet. Okay. Clear? So that we'll discuss in our subnetting part. Okay, like subnetting and all, that we'll discuss. Basically, like that is subnet mask and all. Okay. Here also I'm going to discuss like what is subnet mask and all, okay, in our next rules. But basically this subnet mask, okay, it defines the network ID portion and host ID portion. Okay, that means like in how many bits we have the network ID. Okay, that should be same, okay, to create a network. Okay, so that we'll discuss later on, okay, in these rules itself. Clear? Furnace. Okay. Now, so rule number 4 is first octet of an IP address always define your class of the IP address. Okay, so that is your rule number 4. So we already discussed these examples as well. Okay, so let me till now whatever we discussed, okay, let me show you this. Okay, let me first explain next rule also. Okay, then we'll discuss the practically, okay, whatever we discuss. Okay, so rule number 5. So rule number 5 is what? Like we can use class A, class B and class C only. We can use class A, B and C only. Okay, we can use these 3 classes only, okay, to configure a network device or our systems. Okay, we can use these only. We cannot use class D and E. Why? Because class D and E are reserved for multicast and research and development. Okay, R&D. Okay, so respectively, we can say respectively. So basically this class D, it is reserved for multicasting. Okay, and class E, this is reserved for research and development. Okay, so what we discussed so far, we can use what? We can use class A, B and C only. So that means we can use from 1 to till 223 only in the first octet. In the first octet, how many numbers we can use? In the first octet, we can use from 1 to 223 in the first octet, because first octet always sorry, first octet always define your class of the IP, right? Yes or no? Okay, so in first octet we can as per the rule, we can use what? We can use class A, B and C only. So in first octet we can use these numbers only, 1 to 223. Okay, because till 223, that is your part of class C. Okay, clear? We cannot use like 224 or 250 in this first octet. Okay, but here we can use any number like from 0 to 255, because these other octets, they are not defining any class of the IP, right? Yes or no? Correct? So yeah, correct. That also we can't use. Yeah. Okay. Yeah, there is a calculation. Okay, this is the easiest way to understand, and if you want to understand that, then that you can check. Okay, there is a mathematical calculation. Yes, there is. Okay, clear? So that will be like in the bits and all, you have to convert, and then you have to specify like this is the range for class A, this is the range for class B. Okay, but this is the simple, like you can understand, right? Like from 1 to 127 or from 128 to 191, this is your range. Simply you can like understand it, right? Because that calculation is little bit lengthy also, and it's not easy to understand. Okay, for each and everyone, I can say it can be understand. Okay, you can understand it. It's not like you can't understand, but you have to like give more attention on that particular. Okay, clear? Yeah, so this is your rule number 5. That means like we can, in first octet we can use class A, B and C only. We cannot use class D and E. That is why we can use only these numbers here. Okay, let me show you this practically. So let me open this. Okay, and let me it's visible, right? My network adapters, you are able to see, right? Yeah, okay. So now suppose I want to like configure some IP addresses here. Okay, so whatever we discussed, like from rule number 1 to rule number 5, that we'll discuss. Okay, so first thing, like we discussed, like this is your rule number 1, right? It is 32-bit address and divided by 4 octets, and each octet divided by a separated by a dot sign, right? Yes or no? Okay, and also we discussed like each octet can have minimum value 0 and maximum value at 255. Okay, but we cannot use 256. See, 256 is not a valid entry. Clear? I specified here 256 on this last octet. Okay, it gave me an error that like 256 is not a valid entry. Okay, it is saying that like we can specify the value between 0 to 255 only. Okay, clear? Any doubt? So this was your like we can say first second rule, right? See, second rule is what? Minimum value 0, maximum value 255. So that is what I'm showing here. So we can use here 0 minimum value, we can use here 255 also, we can use here 255 also, like this. Okay, I'm using here like 10, so it will accept it. Okay, we have to assign the subnet mask. Now it will accept it. See, assigned. Clear? If I go to properties again, see, this is the address I assigned. So I used here 0 also, I used here 255 also. Clear? That is your rule number 2. Okay, now rule number 3, we discussed like there are ranges. Okay, there are 5 classes and there are ranges for each and every class. So this 10, that means this is your class A IP address. If I talk about here 172, okay, .0.255 like this. Okay, so wait, let me assign it again. 172.168.0.1. okay, like this. Okay, see, this is your class B IP address. Okay, 172, this belongs to class B. Similar, if I use here 192.192.0.0.1 like this, so this is your class C IP address, because 192 belongs to class C. Clear? And also in rule number 4 we defined like that represent your class of the IP. Okay, So once next rule is about your subnet mask only. Okay, so we'll discuss about like what is subnet mask and all. So after that you can able to understand, like if I'm giving here 192, that means this is your part of class C. If I'm using here like 150, if I'm using here like 150, so that is your class B IP address. If I'm using here like 10 or 100, okay, so that means that is your class A IP address. So once we discuss this subnet mask, okay, in our next rule, so you can easily identify that this is your class A IP address, that is your class B IP address, and the other one was class C IP address. Okay, so that we'll discuss in next rule itself. Okay, and also I discussed like our fifth rule was about we can use class A, B, and C only, right? Okay, and also I told you like we cannot use 0. See, when I assigned here a value 0, see, let me assign it again 0. Okay, and if I go to this next octet, see, 0 is not a valid entry. Please specify value between 1 to 223. Even this is like saying to me that like we have to assign a value between 1 to 223. That means we can use up to class C only, right? Okay, that is what I discussed here. Correct? See, in first octet we can use from 1 to 223 only. Okay, so even if I want to use here, like suppose if I want to use suppose 255, okay, it is not taking. Okay, even if I'm going to use here like 230, it will not take. See, 230 not a valid entry. I hope it is clear, right? Any doubts so far? Okay, so like in first octet we can use till 223 only. Even it is showing me, right? Okay, even we cannot use 127 because this is used for loopback address. Okay, clear? So this message itself, it is saying that like we can use the values between 1 to 123. Okay, this 127 also reserved, so we can use here like 1 dot. Here you can use any number, like I'm going to use like 240, in other octets like 255, and here also I'm going to use like suppose 0. Here I can use here 0 also. Okay, see, it will take. Done, right? It's taken. Why? Because this is not your first octet. Okay, this is your last octet. That's why it is taking it. Okay, but there are some cases where you cannot assign 0 in your last octet. That we'll discuss later. Clear? So for that you have to understand first like what is subnet mask. That we'll discuss in our next rule, and then we'll discuss like where we can use 0 or where we cannot use 0, like that. I hope it is clear till now. Each and every rule we discussed, right? Any doubt so far? Anyone? Dhruv, Farnaz, SP, Kaushik, Naveen, Saurav, Suhail, Vinay. Okay, thank you. Loopback address, basically it is used to check the self connectivity. Okay, so basically like to check your own LAN card connectivity. Okay, to check the LAN card, whether our LAN card is working properly or not. Okay, you can just give a command like ping. Okay, ping command to check the connectivity, and you can give an IP address like 127.001. Okay, so like this, if it is reply is coming from 127.001, reply is coming, that means your LAN card is properly working. Okay, and if it is reply is not coming, okay, if it is failing, so that means there is an issue with your LAN card. Okay, so to check the self connectivity, this loopback address, this 127 address is used. Okay, yeah. Now we are going to discuss our next rule, that is your rule number 6. So till now we discussed there are 5 classes, right? Okay. Rule number 6 is like each class has its unique subnet mask. Okay. So first of all, what is a subnet mask? What is a subnet mask? Anyone? No. Basically, like in simple words, if I tell you, like subnet mask, it defines your network ID portion and your host ID portion. Like in how many bits you have network ID and how many bits you have host ID portion. Okay, so that is your subnet mask. So we can say it defines your network ID and host ID portion. Okay, so your IP, okay, suppose whatever the IP, okay, so that is divided into your network ID portion and there is a host ID portion. Okay, clear? So using the subnet mask you divide it. Okay, clear? You represent your network ID and host ID. So how you are going to represent that this is your network ID and this is your host ID in the subnet mask? So basically I can say there are bits, right? Okay, so whatever the on bits are there, on bits means ones, right? Okay, on bits represents your network ID portion. Okay, and whatever the off bits are there, okay, in the subnet mask, whatever the off bits are there, that means all the zeros, that represents your host ID portion. Okay, so let me take an example. So for example, if I take a class A subnet mask, okay, for class A, your first octet, okay, in this is your subnet mask, okay, subnet class A subnet mask. Okay, so for class A subnet mask, your first octet, your all the bits will be on, okay, and all remaining bits, all remaining 24 bits will be off. Okay, clear? So that means in class A, your first 8 bits represents your network ID, okay, and remaining 24 bits, these are 0, right? Yes or no? So how many bits are 0? 8, 8, 8, total 24. So these 24 bits represents your host ID portion. Any doubt so far? So this is your binary format, okay. If you represent this in decimal format, so all 1, so that means that is your 255, yes or no? That we discussed earlier also, right? Here in rule number 2, all the bits are 1, right? On. Here all the bits are on, okay, in a single octet. So that means that is your 255 value, right? So if all the bits are on, so that means that is your 255, and if all the bits are 0, that means that is your 0. Clear? Okay, so this is your subnet mask, okay. You can represent in this way or in this way, okay. So this is your into your binary format, okay, this is your into your decimal format. Clear? So this is your class A subnet mask. So basically it defines what? 255, that means your first octet, your first 8 bits, first octet, that is your network ID portion, and remaining 24 bits, that is your host ID portion. That means you can connect your users there. Okay, you can connect your host. Clear? And in next rule, you will come to know like what is the use of network ID and what is the use of host ID. Clear? As of now, just understand that like your on bits represents your network ID, your off bits represents your host ID. Okay? I hope all clear till now. Similar. So this is your class A. Let me come to this way only. So if I talk about class A, so class A, I'm talking here about subnet mask. Okay, so class A subnet mask is your like 255.0.0.0. So that, as we discussed, like first octet is your network ID portion and last 24 bit, that is your host ID portion in class A. Okay, similar for class B, your first two octets. Okay, so for class B, your first 16 bit will be on. Okay, so that means your first 16 bit, that is your network ID portion, and remaining 16 bits, that is your 0. That means that is your remaining 16 bits, those are your host ID portion. Any doubt? Similar for class C. Okay, so if you talk about class C, so in class C, first 24 bits that will be on. Okay, in the subnet mask. So first 24 bit will be on. So that means first 3 octet that represents your network ID, and last octet, that's your last 8 bits. Okay, that represents your host ID. Clear? Any doubt? Okay. Yeah, correct. That depends as per the requirement. Okay, like if it is very large, okay, in numbers, like, so then we use like class A, otherwise usually like class B or class C is enough. Okay, so class C is used for in the small networks, and if it is like the users are in number of thousands, like that we can say, so that is we use class B. Clear? Yeah, okay. So now we'll discuss about our next rule, that is your rule number 7. Rule number 7. So now you will come to know like what is the use of this network ID and host ID portion. Okay, so this is all about we are discussing about to create a network, right? Okay, so now if you want to connect the devices, okay, in a single network, so for that your network ID must be same and your host ID must be different. Okay, to create a network, a single network, okay, we can say, so we can say like to create a single local area network, a single LAN, our network ID must be same and host ID must be different. Okay, so for example, like if I want to connect like 4 or 5 PCs, okay, in a small local area network using a switch, okay, so I have to, like, first of all I have to make the physical connectivity, that I already achieved that. Okay, now I have to make the logical connectivity using the IP addressing, right? So we have to assign the IP addresses. So for first user, okay, I'm going to assign like suppose 10.0.0.1. okay, so now you can easily understand, right? So there are dots, why I'm using the dots and all. Okay, so because this is the only representation, this is how we can only define the IP address, right? Okay, so 10.0.0.1 for the first PC, 10.002 for the second PC, 10.003 for the third PC. Similar for this last PC, I'm using like 10.005. Okay, but here I'm using, suppose instead of 10 I'm using like 11.004. okay, so now here if you see, this is which class IP address? 10 is belongs to class A, right? So class A subnet mask is what? Class A subnet mask is 255.0.0.0. okay, that means first octet defines your network ID. That means what we discussed here, to create a network, okay, to create a single local area network, our network ID must be same. Okay, so that means our first octet that represents our network ID, so that means our first octet must be same. So here 10, 10, 10, 10, and this is 10 or different? This is different, right? Okay, so that means like this is part of a different network. Our network ID is not same, okay, for this particular IP. Okay, clear? So that means like these PC, they can able to communicate, like who are using the 10th IP address, okay, like 10.1, 10.2, 10.3 and 10.5. They will be able to communicate, but they will not able to communicate to this fourth one. Clear? Why? Because this belongs to a different network ID. Clear? Yeah, this belongs to class A, but if you represent this 10, okay, into bits, okay, so 10 is what? Like this, right? Yes or no? Okay, this is your bits, right? In the 8 bits, this is how you will represent 10. Okay, so like this is your 2 and this is your 8. 8, 2 plus 10. Okay, but 11, how you will represent? 1, 0, 1, 1, like this. So now tell me, like, whether both are same or different. Both belongs to class A, but both are different. Clear? So that means first octet, that should be same. Clear? And as per the rule, host ID must be different. Okay, it's not like you are using here like 10.0.0.1, okay, and here I'm using like 10.0.0.1. okay, you cannot use that. Clear? Okay, so host ID here what? 0.0.1. okay, all bits 0, all bits 0 here, and here 7 bit 0 and last bit is on. Similar for this, but I can use, instead of this, okay, I can use like 10.0.1.1. this I can use, okay, because this is different from this. Yes or no? Correct? Okay, clear? Yeah, so that is the use of subnet mask. Okay, this defines your network ID portion and host ID portion, so which is used to create our local area networks, because to create a network, our network ID must be same and host ID must be different. I hope it is clear now. Any doubt to anyone? Okay, so first of all, let me show you this here. Okay, the subnet mask and all, whatever we discussed, okay, in rule number 6 and rule number 7. Okay, so it's visible, right? Network adapters, yeah, it's visible. So if I go to properties here, and if I go to here IPv4 properties, so if I take an example of class A IP address like 100.0.0.1, 100 belongs to class A, right? So if I press a tab button, so it will automatically taking the subnet mask, see, 255.0.0.0. So that is what we discussed. For class A, your subnet mask is what? 255.0.0.0. Yes or no? Okay. Similar, if I take example of class B, like 150.0.0.1, so 150 belong to class B, correct? So once I press tab here, see, automatically it is taking 255.255.0.0. I'm not assigning it manually, right? Once I press tab, it is automatically assigning it. Okay, so this is your class B subnet mask. So that is what we mentioned here. See, class B first 16 bit is your network ID portion. Similar here. Okay, and same for class C now. So like suppose 192.0.0.2. okay, see, for subnet mask for class C is like first 24 bit is your network ID portion and last octet, that is your host ID portion for class C. Okay, and here like two classes are left, right? So class D and class E, these are reserved, right? So we don't use it, so these are not applicable. Okay, we can say not applicable, okay, for the subnet mask. Clear? Okay, because we cannot assign the subnet mask, right? We cannot assign the IP address also, right, for class D and class C. Okay, so this is your like subnet mask that we discussed so far. Okay, now our next rule, that is your rule number 8. So rule number 8 is like how we can allocate or assign the IP address on our device or our system. Okay, so how to define, or we can say allocate IP address on a device. Okay, so how you can define it or how you can allocate an IP address, okay, on a device, whether it is a router or a PC, okay, whatever it is. So how you can define it? So there are 4 octets, right? Okay, so in first octet we already discussed 0 is reserved, we cannot use. 127, that is also reserved, okay, we cannot use. Okay, so these 2 numbers we cannot use, and also we can use up to 3 classes, right? Class A, class B and C only, correct? So that means in first octet we can use from 1 to 223, yes or no? Okay, in second octet we can use from 0 to 255. Okay, in third octet also we can use from 0 to 255. In last octet also we can use from 0 to 255. But there is one rule. Okay, what is that rule? Rule is that like if I talk about for each and every class, okay, like for each and every class, like suppose if you are going to assign an IP address of class A or class B or class C, okay, so all the bits of our host ID portion neither be 0 nor 1. Okay, neither be off, or we can say nor on. All the bits, okay, I'm talking about here all the bits of your host ID portion. Okay, what does that mean? Suppose if I talk about class A example, so in class A my subnet mask is what? 255.0.0.0, right? This is my subnet mask, right? So if I'm going to assign IP address for class A, suppose an example of class A IP address is I'm taking like 10, okay, 10 range, okay, IP address of 10, okay, so suppose 10. So now in host ID portion I cannot use all the 0, okay, so all the bits of host ID portion it cannot be 0. That means here it cannot be like this, okay, my IP address cannot be like this. Or else like in host ID portion it cannot be like all the bits are on. That means if all the bits are on, that means what? In host ID portion if all the bits are on, that means 255, right? So that means like 10.255.255.255. Okay, so these 2 addresses we cannot use. we cannot assign, or we can say we cannot allocate to our system or to our device. Okay, why? Because these both are reserved. Okay, basically this defines your network ID. Okay, this defines your like 10.0.0.0, that means that is your network ID, and this very last IP. Okay, so basically this is your very last IP of this. Okay, because now if you add any bit, okay, that means you cannot make any changes here, because this is your already bits are fully, right? Okay, here also all the bits are full, all the bits are on here also. Now you have to make the change here. So once you make the change here, that means that is part of a different network, right? So that means this is what? This is your last IP. Okay, so that is your broadcast IP. Okay, for that particular network ID. Okay, so these two IP addresses we cannot assign. Okay, but it's not like 10.1.0.0. I can assign this. Okay, so you will mention that like you are using here 0 in the last octet. I can use that because why? Because in class A, these 3 octets is my part of host ID portion, right? Yes or no? Correct. So in host ID portion, this bit here, one of the bit is on, right? Am I correct? Okay, so here all the bits are not 0, even all the bits are not on. Okay, so that is why I can use this one, but I cannot use this one, or I cannot use this one. Similar, if I take example for class B, this is class A example. So if I take class B example, so suppose my class B separate mask is what? 255.255.0.0. First 16 bit is your network ID portion, last 16 bit is your host ID portion. Okay, so if I take an IP here from class B, suppose I'm taking 172.16.0.0. Okay, so you cannot assign this IP address. Why? Because first 2 octet defines your network ID portion, right? Okay, and now these 2 octets, last 2 octet defines your host ID, and that is what we discussed here, that all of your bits in your host ID portion neither be 0 nor 1s, right? Okay, all the bits. So that means in host ID portion we cannot use all the bits 0. Clear? So that means you cannot use this one, but we can use 172.16.0.1, like that we can use. Okay, even we cannot make all the bits of host ID on. Okay, we cannot make all the bits on. Okay, so that means 172.16.255.255. Okay, so this is what? This is your network ID, this is your host ID, and host ID all the bits are on, right? Yes or no? Correct? So here all the bits are on, that means that is your broadcast IP. Okay, broadcast IP. Any doubts so far? Similar for class C. Class C, my separate mask is like 255.255.255.0. Okay, and if I take an example of an IP address, so suppose 192.168.0.0. Okay, so this is my network ID portion. So here we have to focus on what? Host ID portion. Okay, so all your bits, if it is 0 here, that means all your bits are 0, so we cannot use this. Okay, even if all your bits are your own, that means 255, if it is 192.168.0.255, that means all the bits in our host ID portion are on. This is also we cannot use. Why? Because this is represents your network ID portion and this represents your broadcast IP. Clear? Okay, so mainly you have to focus on your host ID. Okay, all the bits cannot be off and all the bits cannot be your on. in your host ID of any class, whether it is class A IP address or class B or class C. Let me show you this practically also. It's feasible, right? Okay. So if I go to properties, IPv4 properties, okay. So see, if I take 10.1.0.0, it will take or not? Tell me. Hello? Yeah, it will take it. Okay. See, assigned, right? That particular IP address assigned. Why? Because this is your part of host ID, right? Last 3 octet, and one of the bit is on in our host ID portion. So that is why it is taking. But if I do here like this way, it will not take it. Okay. See, if I press OK, see, combination of IP address and subnet mask is invalid. Clear? And it is saying that like here host address portion of IP address are set to 0. Clear? All the bits, see, all of the bits in the host ID portion. Okay, that is what we discussed, right, in rule number 8. Okay, and also we cannot make all the bits on, right? So if I make it like this way, okay, we cannot assign it. See, all the bits in the host ID portion address are set to 1. Okay, that is why it is here 255, right? Okay, clear? So we cannot assign it. Okay, so it is allowing giving me an error, but I can assign like this way, 0.255.255. This I can assign. Okay, why? Because here 3 octets are your host ID portion. One of the octet, okay, there are some off bits. Okay, even I can assign like 254. Okay, like this also I can assign. See, it will taken, right? Okay, but it will not take 255. That we already discussed. Okay, if I take here 0, it will take it. See, clear? So this is your class A. Similar for if I talk about like class B, 172.16.0.0, it will not take it. Why? Because because last 2 octet defines your host ID portion. Okay, see, it will throw an error. Okay, see, all the bits are 0 in host ID portion. Okay, similar, I cannot assign like all the bits I cannot set as on. Okay, 255. See, it will throw an error. See, okay, clear? But I can assign like this way, 172.16.0.255. This I can assign. Why? Because in this one, this octet, 3rd octet also part of host ID, and this is not on. Okay, some bits are off here. Okay, so it will take it. See, taken. There is no error. Clear? Similar for class C. So class C IP is like 192.168. If I talk about here like 1.0, it will take or not? Any idea? Suhail, Farnaz, Saurav. Yeah, it won't take. Why? Because here last octet is your host ID portion, right? Here host ID is what? 0. In your last octet, all the bits are 0, right? So it will not take. See? Clear? Similar, if I use here like 192.168.0.255, this also it will not take. Why? Because all the bits are on here in the last octet. Clear? See? But other values I can specify. Okay, so like I can specify like 254, I can use it. Okay, it will take it. See, taken. Correct? So this is your rule number 8. I hope it is clear for everyone. Any doubt, please let me know. Anyone? Nayan, Naveen, Vikas, Dhruv, Kaushik. Okay. Okay, fine then. Now we'll discuss our next rule. That is your rule number 9. Okay. So in rule number 9, we will calculate. It's visible. Yeah, it's visible. Okay. Yeah. So in rule number 9, we'll calculate valid hosts in each class. Okay. In each class, how many hosts we can connect? Okay. Valid host we can connect. That we'll discuss. Okay. So if I talk about class C example. Okay. First of all, we'll discuss about class C. So in class C, what is my subnet mask? So first 3 octet, this is our network ID portion and this is our host ID portion, and we have to calculate like how many hosts, how many users you can connect, right? Okay, in network. Okay, in a single network. So if I talk about in class C, so in first 24-bit, that is your network ID portion, that should remain same, right? Okay, so that means like I cannot make any changes in our first 24-bit, correct? Okay, so if I talk about like one example, like one IP address, if I take here like 192.168.0.0, okay, like this is my network ID suppose, okay, /24 means basically this is called as like whatever the slash value, okay, /24, this is called as prefix value, and it defines like in how many bits you have the network ID portion. Okay, so in our next topic we'll discuss about like subnetting and all. Okay, so there you can manipulate this value, okay, this network ID portion value. Okay, so you can use here like /28 or /25 like that. Okay, so that means this prefix value, this defines that in how many bits you have your network ID. Clear? So by default here /24, that means your first 24-bit, that is your network ID portion. Got it? Any doubt so far? Okay, so this is my suppose my first IP. Okay, so now if I want to assign a IP, okay, to any user, so I can give like 0.1, right? Similar to the second user, I'll give like 0.2, correct? Similar, I can give like 3, 4, 5, 6 like that. Okay, so till what we can use from maximum, we can use in each and every octet from 0 to 255, yes or no? Okay, so we can use like from 0 till 255 numbers, we can use 255, right? In each and every octet we can have these numbers, right? Correct? Okay. So how many numbers are there? From 0 to 255, total 256. But as we discussed, we cannot assign this like all the bits in your host ID cannot be on and all the bits in your host ID cannot be 0, right? Correct? So that means total number are from 0 to 2 and -2, because these two IPs we cannot assign, because first one is define your network ID and last one define your broadcast ID. Okay, so how many users we can connect in a class C? Network ID 254. Okay, PC we can say, or user we can say, or host we can say. Okay, 254 host. Clear? Because now at this time we cannot make any changes here because all the bits are on, and if we make change here in this octet, that means that you are going to change in your network ID portion, right? that means that is your part of a different network. Yes or no? Okay. Yeah. So in a single network in class C, you can connect maximum 254 PC. Now we'll take an example of class B. So in class B, if I talk about like subnet mask, it's 255.255.0.0, right? Okay. And in this one, so basically like first 2 octet is your network ID and last 2 octet is your host ID. That means in last 2 octets you can use to connect your host. Okay. So if I take an example for any IP address, okay, suppose I'm taking like 172.16.0.0. Okay. So this is my first IP, suppose, and then I'll assign like next IP like 0.1, 0.2, 0.3, keep on going till what? 0.255, right? Okay. Now I cannot make any changes here, but I can make change here, right? Okay. So now next IP is what? 172.16.1.0. Okay. Similar 1.1 till what? Till 1.255. Okay. Now I cannot make change here. I can make change here. Okay. So here again 2.0, then 2.1. Okay. Keep on going. So till what? So one time will come where we have 172.16.255.255, right? Okay. So now if I make change here, I cannot make any changes here, right? Because all the bits are already like on. Here also all the bits are already on. If I make change here, that means that belongs to a different network ID. Correct? Because this person first 2 octet defines your network ID in your class B. Correct? Okay. So I cannot make any changes here. So only these number of devices or host I can connect in class B. Okay. So how many hosts? You can connect from 0 to 255. That means 256 host you can connect when you are using here 0. Okay. Similar, you can connect 0 to 255 host when you are using here 1, right? Okay. Again 256 host when you are using 1 here. So how many times we are connecting 256? Till from 0 to 255. That means total 256 time we are connecting 256 host, right? But very last IP we already discussed in our last rule, right? Okay. So this is your broadcast ID, correct? So we cannot make all the bits on in our host ID. Okay. Similar, very first IP, okay, this also we cannot use because all the bits are 0, right? Okay. So that means -2. Clear? So 256 multiplied by 256, that is your 65536 -2. Okay. So that is your 65534. Okay. Clear? So these many number of hosts you can connect in class B. I hope it is clear. Any doubt to anyone? This is like these many hosts we can connect in a single network ID. Okay. So in class B we have a range, right? Okay, like from 128 to 191. Okay. So there are lots of IP addresses. Clear? Okay. Now if I talk about class A, in class A, what is your subnet mask? It is your 255.0.0.0, right? So that means last 24 bit you can connect your host and first octet is your network ID portion, correct? Okay. So if I take an example for like 10 only, okay, so /8 means your first 8 bit is your network ID portion. Okay. So for first user I'll assign like 10.0.0.1 and so on, like it will go till 255, right? Okay, when it is 0 here. Okay. Clear? Similar, like it will be 1 here, 1.0, 1.1 until what? 1.255. Okay, again 2.0, 10.0.2.0 till what? Till 10.0.255.255. Now I cannot make any changes here because all the bits are on here, all the bits are on here too, but we can make the changes here. Why? Because this is also, this octet, second octet, this also part of your host ID, right? So now we can make like 10.1.0.0. Okay, like this. So again, same thing. Okay, clear? So till what? One time will come when we have like this value 255, 255, 255. Okay, all the bits are on in our host ID portion. Okay, now if you make any change, so your change will be done here. Okay, so that means that belongs to a different network ID. Okay, so how many PC you connected here? So we connected like 256 PC when 0 is here. Okay, so that means like we are connecting 256 PC 256 times, right? Okay, and again this number of PC we are connecting when 0 it is here, right? Okay, how many times from 0 to 255? Total 256 times. Okay, but very first IP and very last IP we cannot use, right? Because this represent your network ID and this represent your broadcast ID. Okay, so -2. So whatever the number you can calculate and you can mention. Okay, clear? So it will be like 536 multiplied by 256 and -2. Okay, now you can calculate. It will be a huge number. Okay, clear? So that many number of users you can connect in your class A network ID in one single network ID. I hope it is clear. Hello. Okay. Yeah, basically this broadcast ID. Okay, so suppose yesterday we discussed, right, about a broadcast, right? So suppose this is a network. Okay, like this is a network and I'm using here a network, suppose 192 network, class C network. Okay, like 10.192.168.0.1, similar 192.168.0.2, like that, so on. Okay, .3 here and .4 here. Okay, now if this PC wants to send a broadcast message, that means like it want to send a message to all the devices which is connected in this particular network. Okay, so what it will use? It will use that particular broadcast IP. Which one? 192.168.0.255. It will use this address. Clear? Okay. Yeah, I'm just giving an example. Okay, like this is how it is used. If any device, suppose if a router wants to send a broadcast, okay, correct? So that understand the IP address and all, right? Layer 3 address. Okay. Now, your last rule, rule number 10. So rule number 10, basically, if I talk about this IPv4 address, okay, this IPv4 address further divided into two parts. Okay, basically INA is there, right? That Internet Assigned Number Authority. It divided your IPv4 address into two parts. IPv4 into two parts, that is your private IP and public IP. Okay. So your IP address, IPv4 address, that is your, there are two types of IPv4 address. One is your private IPv4 and other one is your public IPv4. Okay. So what is the difference between private IPv4 and public IPv4? Basically, like these private IPv4 address, these are free to use. Okay. So for example, like I have to connect like 4 or 5 systems, okay, like in a small network, and I want to communicate between those systems only. Okay. So what I have to do, like I can use a private IP range. Okay. Why? Because these are free to use. Clear? Okay. But these public IP addresses, these are paid. You have to pay for it. For example, like you are going to access internet, right? Okay. You are taking a internet connection. Okay. For that you have to pay, right? Yes or no? Correct. So there will be a like kind of we can say a public IP address assigned. Okay. Using the public IP address only, you are communicating to the internet. Clear? There is like in between there is netting and all performed. Okay, that we'll discuss later on what is net and all. But there is somewhere we are using some like somehow we are using some public IP address through which we are communicating to the internet. Okay, so these private IP address, these are free to use and used in local area network, LAN. Okay, and these public IP addresses, these are used in WAN, or we can say in our internet. Clear? Okay, so like it's not like you are configuring a private IP in your system, okay, and you can access the internet. It won't be possible. Okay, clear? So using public IP only, you can able to communicate to the internet. That I'll show you. Okay, practically also. Now, if I talk about like what are the public, what are the private IP? Okay, if I talk about like in classes, so there are predefined private IPs. Okay, so if I talk about in class A, if you talk about here, private IP range, so basically the 10's range, right? 10 IP address. So 10 dot like 0012, 10 dot 255 dot 255 dot 254, because 255 is your broadcast, right? Okay, so this is your range for your private IP in class A. Clear? Similar, if I talk about class B, so there is a range like 172.16.0.12, 172.31.255.254. Okay, similar, like this is the range in class B for the private IP. Similar for class C, there is a range like 192.168.0.12, 192.168.255.254. Okay, so this is the range in class C. Okay, apart from this, there is a PIPA range, okay, where like it is assigned by a DSCP server. Okay, so that will be discussed later on when we discuss about the DSCP and all. Okay, and apart from that's it. Okay, so these are the ranges basically. Okay, in class A, class C and class C. Clear? So apart from like these ranges, okay, if I talk about like class A, okay, apart from like 10, okay, class A range is what? From 1 to 127. Basically like 127 also we don't use, we use from 1 to 126, right? Okay, 127 also reserved for the loopback, right? Okay, so 1 to 126, that is your total range in class A. But 10 range, see here 10's range, whole range is reserved for private IP, right? So here in public IP, in public IPv4 class A ranges, you can say from 1 to 9, okay, and from 11 to 126. All the ranges belongs to public IP. Clear? Similar, you can exclude this particular range, okay, and all other ranges, okay, from we can say from 128 till we can say till 172.15.255.254, okay, till here, okay, because next one is going to be broadcast and after that it will be your 16.0.1, right? Okay, so from 128 till 172.15 particular this IP address, okay, till what, till like from till this one, and from 172.32.0.1 to we can say 191.255.254, okay, like this. So that is your class B public IP range, okay. So these are the ranges. Clear? Similar, if I talk about like class C, you have to exclude this. Apart from this, all other ranges, okay, like you can exclude like this particular 192, 168, okay. Apart from this, all other is your public IP address. Clear? Any doubt? Anyone? Dhruv, Farnaz, Kaushik, Naveen, Nayan. Yeah. Okay. And even like you can also check it like if I open my network settings, okay, you can see I'm using Wi-Fi, my internet, right? Okay. Right now I'm able to access my internet, but once I configure here a like private IP address, okay, your internet will be gone, okay. So by default it is assigning automatically C, but if I do here like 10.0.0.1 a private IP address, if I use here, my internet is gone. Okay, so now I signed it back, so now it is connected again. Hello. Hello. Yeah, clear, right? So like if you have to use the internet, okay, you have to use the public IP, okay, because these private IP used in our local area networks only, so they cannot communicate to the WAN. Our LAN cannot communicate to our WAN, okay. Our internet, like if you are not using any net and all, net service and all, okay, if you are not using net service, in that case it will not communicate. But if you are using like address translation and all, then there is possibility. Clear? So that topic will be discussed later on. Any doubt in this difference between IPv4 and difference between private IP and public IP? And any doubt in this IP addressing, IPv4 addressing? Okay. Okay, fine then. So that's it for today. Okay, like we already like covered IPv4 addressing. Okay, and IPv6 addressing we are going to discuss like later on. First, we'll discuss like our next section will be on subnetting part. Okay, clear? Yeah. So okay, then see you in the next class next Saturday. Okay, at the same time 3 o'clock. Sorry. Yes, please. that is what yeah, that is what I'm saying. I discussed earlier also in this class. So once we're done with this subnetting and OSI model and all, right? Okay, so we'll have a separate session, okay, like separate discussion on like packet tracer, okay, how to install packet tracer, because in starting right now you don't need to install GNS, okay, so you just need to install like packet tracer, because for GNS, okay, there is a huge requirement, okay, like your system should have a high RAM also, okay, and you need like real iOS images also, right? Okay, those are the requirements there in the GNS, okay, and it will slow down your system also. But this packet tracer, this is a lightweight software, okay, you don't need to install any iOS images and all, okay, there are predefined routers, everything is there, okay. So we will have a session on this packet tracer, how to install it and how to use it, okay, so that we'll discuss. But we'll discuss that like once we're done with this OSI model, those things, okay, basic theory, okay. So but before the basic command and all, before that we'll discuss this, so for each and every one, so that like you can install it properly in your system and you can make the practice, okay. So any doubt for anyone else?